All right, everybody. So today we're going to talk about converting from polar to rectangular coordinates. As a reminder, there are no more daily quizzes, and your My Math Lab that was on last session's um, information, which was graphing polar coordinates, is due on Monday. That's already available. It's been available since Tuesday. And there is a new one now open, and that is due next Wednesday. So you have one due Monday, one due Wednesday on last session's information, and now on this session's information. All right, let's talk about polar and rectangular coordinates. So basically, the whole goal today is to be able to switch back and forth between polar coordinates and rectangular coordinates. So let's take a look first at those two systems kind of overlaid here. You can see if we pick any one point in both of those systems, then we can define that point in rectangular coordinates by x, y, and we learned last class how to define that point using polar coordinates with r and theta. So if you go ahead and draw in your coordinates for each value, on your rectangular coordinates, remember x is your horizontal distance and y would be your vertical distance to get to that point. In your polar coordinate, then your r distance would be the distance from the point to the pole, and the theta would be the amount of rotation that you need to get to there from your axis. So you can see all of those kind of in that same coordinate system with their parts labeled. Now, based on that picture, we can go ahead and come up with some relationships that we already know about. So first, you can come up with the idea that x squared plus y squared equals r squared. That's your Pythagorean theorem because that is indeed a right triangle. So you can go ahead and write that equation out. And then you can also use your basic trig functions. Cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and tangent is opposite over adjacent, to go through and come up with some ratios for each of those sine, cosine, and tangent functions. So that's all your basic trig right there. So we know all of that information. It was just putting those pieces together based on that information that we already knew. Now, what are we going to do with all of these things? Well, in their current form, we can't really do anything with them. So we need to go ahead and solve them for a couple of things so that we can find some values that we're looking for. So in these two middle functions, the sine and the cosine, we're going to go ahead and solve for x and y. And in those top and bottom functions, we're going to solve for our r value and our theta value. The r value is just to take the square root. For all the other trig value functions, for cosine and sine, we're going to multiply by r, and then at the bottom, we're going to take the inverse tangent. So if you look, here's our manipulated equations. So we went ahead and took the square root of r. Remember, when you take the square root, you get a plus or a minus answer, and that's going to give us two answers for all our r values, and we'll talk about that in a minute. For the x and y, we multiplied both sides by r, and that gave us r cosine theta or r sine theta, depending on if it was x or y. And then finally, in the bottom, to get theta by itself, we took the inverse tangent of y over x. Now remember, inverse tangent is going to give us one value, but we can come up with multiple values based on the fact that it's a periodic function. So if you add the period to your answer when we do this inverse tangent, you're going to be able to get another set of angle measurements that we will use in our problems. So there's your manipulated equations, and those are the ones we're actually going to use to convert back and forth from polar to coordinate, depending on which one we start with and which one we would like to end up with. All right, so just as a reminder, these are all the functions that you'll need again in this yellow box, and there's another polar coordinate system again with all of the things labeled that we did before. Okay, so there's the functions that you'll need to know to be able to convert from polar to rectangular. All right, let's take a look before we go to calculator. Let's take a look at doing that. So here's my first problem. We're going to convert from polar to rectangular. So since I already have an r and a theta in my problem, I know that I need to use the equation x equals r cosine theta and y equals r sine theta to help me find my x and y values. I know r is 3. I know my cosine, my theta is 5 pi over 6. So I'm going to plug those in and get 3 cosine 5 pi over 6 and 3 sine 5 pi over 6. Then you go through, evaluate your trig functions using the unit circle. So notice I left my r value alone and just plugged in those inverse functions. Where you'll need to look those up on your unit circle if you don't know them by heart. And then we're going to just multiply across. Remember, if you do a whole number times any fraction, the whole number is over 1, so that number is going into the numerator. So that gives me that my x value is negative 3 radical 3 over 2, and y is 3 over 2 for a point that is negative 3 radical 3 over 2, comma, 3 over 2. So if I were to graph this rectangular point and this polar coordinate, we would end up in the same place if those two graphs were on top of each other. Okay. Likewise, we can do the same problem or the same steps for Q. This time though, remember that you have degrees, so we're going to have to use our calculator for that. We cannot use our unit circle. That means I'm going to just straight up type that right in my calculator. Make sure your calculator is in degrees, please, because that is, of course, in degrees. So you type in 2 cosine negative 200 and 2 sine negative 200, and you should get negative 1.88 and 0.68. So those come straight from your calculator there if you have them in degrees. So there's your little reminder. Don't forget to make sure it's in degrees. All right. Now, if we're going the other way, it's going to be a little more complicated because each of those x and y points can actually come from 2 different r values and then 2 different angle measures. So how do we know there's 2 different r values? Well, remember when we were solving that equation for r, we had a plus or minus because we had to take the square root. So when I plug these values in, I'm going to get a plus or minus answer for my r value, which means I could either go to the left or to the right when I'm talking about my r value. If I go to the left, I'm going to have to rotate a different amount. If I go to the right, I'm going to have to rotate a different amount than I did before. So if I go through and plug in my x and y's to find my r value, I have negative 1 squared and 1 squared. That gives me the square root of 2, plus or minus the square root of 2. Sorry, I forgot to write that on my thing. This one should be square root. So when you have plus or minus the square root of 2, then you're going to go through and think, okay, if I went positive square root of 2, that is over here to the right. And if I'm trying to get to point P, which rectangularly I plotted at negative 1, 1, if I was talking about polar coordinates and I started at positive radical 2, how much rotation would I need to get to here? Well, that would be a different amount of rotation as if I went negative radical 2. That would be a different amount of rotation. So what are those rotations? That's where this second equation comes in. So if I go through and I try to find the inverse tangent of y over x, I go through and I plug in my y value and x value for 1 and negative 1. And then I'm going to use my calculator or the unit circle to find out that the inverse tangent of negative 1 is at negative 45 degrees or negative pi over 4 degrees. That's all well and good, but remember we talked about that there should be a second angle measure there. And if you remember on your tangent function, you can find all the next solutions for your inverse functions by simply adding the period. So if I take negative 45 degrees and I add the period for tangent function, which is 180 degrees, then I get my second angle is 135 degrees. If you do that in radians, you take negative pi over 4 and add pi to it, and you get positive 3 pi over 4. So the 2 angle measures I have to pick from are this negative 45, negative pi over 4, or 135, 3 pi over 4. So depending on which direction I'm going, I might have to rotate a different amount. Okay, so let's think about this. If I went to the right, and if I go back over here to my picture, so if I went to the right, radical 2, then I'm clearly going to have to rotate more than 90 degrees to get to that point P. So if I rotate, or if I start with my r value of square root of radical 2, then my theta has to be greater than 90 degrees. So that has to be the 135 degree measure or the 3 pi over 4, depending on which way you want to write it. If I go to the left, negative radical 2, then I clearly only have to rotate a small amount up, which would be clockwise, so that has to be a negative angle. That means that if it's negative radical 2, then our angle must be negative 45. So really you should have 2 different answers here, and then you can write them in either radians or degrees. So you should definitely have radical 2 and negative radical 2, and then their corresponding angle measurements in either degrees or radians. You do not need to have all 4 answers. Just make sure you read the directions for which value they want the answers in. Okay. All right, let's take a look at one more here. So again, my point is negative 3, 0. So that makes the r value math arithmetic very easy. So we're going to go through and we end up with plus or minus 3. That means we can either go 3 to the right or 3 to the left, and that will give us a different amount of rotation that we'll need there. So I go through, plug in my values for my tangent, find my inverse tangent. It turns out that the inverse tangent of 0 is 0. That's great, using your calculator or unit circle. So then my other angle, remember, is to take that theta and add the period to it. So if it's 180, if you're doing degrees, or pi if you're doing radians, because the tangent function's period is always pi unless there's a b value. And then if we go back to our picture, and if I went to the right 3, then you'll notice I need to rotate 180 degrees to get to my Q. If I go to the left, negative 3, then I'm at point Q and I don't have to rotate at all. So if my R value is 3, then your theta must be 180. And if my R value is negative 3, then my theta value is going to be 0. So again, you can write them in either degrees or radians. You don't need both. But you should have a 3 answer and a negative 3 R value for each of those. All right, now let's talk about doing this on your calculator. So you can use your calculator to help you out. You need to use that angle menu, which we did when we did degrees, minutes, seconds. And you get to that angle menu by pressing the second button and then the apps button. Using 5, 6, 7, or 8 will change you from rectangular to polar or polar to rectangular, depending on which one you're trying to find. Notice you're going to have to do this twice for each problem, because some of them only find R, some of them only find theta, some of them only find X, some of them only find Y. So you're going to have to use 5 and 6 for a problem, or 7 and 8 for a problem. So let's take a look. Let's just do the first practice problem that we did, where we're going to change our polar coordinates to rectangular coordinates. So I'm going to do second apps, and I'm going to choose polar coordinates to rectangular coordinates. So I'm going to choose 7, which would be go from polar to rectangular and find the X value. The values that they gave us in that first group were 3 and 5 pi over 6. So I'm going to type those in as my values. So that's my R value and my theta value. And again, we're telling our calculator, change that from R comma theta to rectangular, and I want the X value. So it does all of the calculations you need, and it spits out that your value over here should be 3. And then number 8, 3, comma, oops. 5 pi over 6. And then there's your Y value. So that point in, that's why it's wrong. I'm sorry. My bad. I'm still in degrees when I should be in radians. Try that all again. Sorry, I'm just going to copy that. And go up one more. Copy the Y value. There we go. So there's our negative 3 and 1.5 values that we should have gotten for our answers. All right. So let's go through then and find our distance between our two polar coordinates. So if we obviously know how to find our distance. If we are finding rectangular coordinates, you did the distance formula a long time ago in geometry, in algebra 2. We're going to do the distance between two polar coordinates. And the distance formula for between two polar coordinates is a variation on law of cosines. So you'll see right there, you're going to take your two R lengths, which would be your R and your S value in this particular problem. And then you'll do minus 2 times RS, and then you'll do times the cosine of the two theta values subtracted. Make sure that that is a positive value, otherwise you won't be able to find the cosine. So we're going to go through, and here's our example problem. We have our two R and S values, or they would be our two R values. And then 70 and 150 would be our two theta values. Plugging those in, I get the distance squared is 3 squared plus 7 squared minus 2 times 3 times 7 times the cosine of 150 minus 70. Again, make sure your calculator is in degrees when you type in this part. Type that whole thing in, and you get 50.707. Because it's the distance squared, we have to take the square root of both sides. That will give us the distance. So we're going to take the square root of 50.707, and I get 7.12. Remember, we don't need to worry about our negative values here because negative distance doesn't exist. So only positive distance there. Okay. Let's take a look then at our last practice problem, because that's another distance problem. So when we talk about this particular distance, what they gave you is two polar coordinates of two airplanes based on their radar. Then they want to know, okay, how far apart are those airplanes? Realistically, that would be a great problem to find out. If I knew where they were, could I tell how far apart they are so that we don't have them flying into each other? So we're going to go through, and we have our two R values of 8 miles and 5 miles. Our two theta values are 110 and 15. Plug those in the appropriate places. So 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 110 minus 15. Get my calculator out, type that whole thing in, and I get 95.972. Because it's the distance squared, I need to take the square root of both sides, take the square root, and I get approximately 9.8 miles. Okay. So that is the next section with the MyMathLab due on Wednesday. Remember, the information from last session is the MyMathLab due on Monday. If you have any questions, we will be having office hours on Thursday, virtual office hours on Zoom on Thursday from 10 to 12.